Hi everyone, let's continue our exploration of algorithms. Now, let's look at breadth-first search and depth-first search. These are fundamental algorithms used to efficiently traverse a graph, from node A to node G, for example. Let's start by importing libraries like NetworkX and Matplotlib. Let's create the graph using NetworkX and add the nodes. Then, let's define the depth-first and breadth-first search functions. The principle is simple. Depth-first search chooses a branch, traverses it to the end, and then starts again with another. Breadth-first search explores the immediate neighbors of a node before moving to the next level. Let's visualize everything with Matplotlib and a short animation. Enjoy! Let us continue with the topological sorting, an algorithm used to sort out an oriented graph and give it an order. We begin by imprinting the collections for collections, Matplotlib for plottings, and NetworkX for graph managing libraries. We create the graph and add to it all needed nodes, but no loop in it. Then we create the function managing the algorithm. The principle is simple. At first, we determine the degree of each node by counting the number of edge entering it. Then make and list the ones with 0 degree. For each element of the list, verify the neighbor and delete the edge going to it. If its degree fall to 0, add it to the list. Then lately verify if the final topological sort is complete. We now plot the process using Matplotlib. Please enjoy. Here we go with a third one, the max flow of the Ford-Fulkerson algorithm. Its purpose is to calculate the maximum stream flowing from the source to the sink while respecting the capacity of each edge. In real life, this algorithm is mainly used in logistics and network optimization. It helps determine the maximum quantity of resources that can be transferred from one point to another through a constrained network. These resources can be data packets in communication networks, vehicles in transportation systems, goods in supply chains, fluids in pipeline systems. Then in the program, just like before, firstly, we import the necessary libraries. Secondly, we create and modify the graph structure. Thirdly, we apply the algorithm to compute the maximum flow with the function. More formally, the Ford-Fulkerson algorithm computes the maximum possible flow in a flow network by repeatedly finding augmenting paths and increasing the flow along them until no more improvement is possible. Fourthly, we plot the graph with Matplotlib, clearly showing the source, the sink, the edges, and their capacities, from start to end with labeled axes. Enjoy the show!